Welcome to Across the Globe. Today we will learn about K-nearest neighbors, KNN. K-nearest neighbors, KNN, is a straightforward algorithm employed for classification and regression purposes. It belongs to the category of instance-based learning, also termed lazy learning. In this approach, the algorithm approximates the function solely in the local vicinity, deferring all computations until the evaluation of the function. The operation of KNN involves identifying the k nearest data points within the training dataset to the new data point. Subsequently, classification or regression is executed by determining the predominant class or calculating the average outcome from those k neighbors. For example, in a scenario of classifying emails as spam or non-spam, KNN would classify a new email based on the characteristics of its k closest neighboring emails from the training set, ultimately labeling the new email accordingly. The K-nearest neighbors, KNN algorithm is a simple yet effective machine learning technique used for both classification and regression tasks. 1. Start by selecting the number of neighbors denoted by K. 2. Compute the distance between the new data point and all existing data points in the training dataset using a metric like Euclidean distance. 3. Arrange the distances in ascending order and pick the k neighbors with the smallest distances. 4. For classification, assign the new data point to the most common class among its k nearest neighbors. 5. For regression, assign the new data point the average of the target values of its k closest neighbors. For instance, in a scenario where you aim to predict whether a person will like a specific movie based on characteristics like genre, runtime, and cast, you could use KNN to identify how similar their preferences are to individuals who have previously watched and rated similar movies. If most of their k nearest neighbors positively rated the movie, the algorithm would predict that the person will also like it. To classify data using the k nearest neighbors KNN algorithm in Python, you first need to import the neighbors classifier class from the sklern.neighbors module. Then, create a KNN classifier instance with a specified number of neighbors, for example, neighbors classifier and neighbors3. Next, train the model by fitting it to the training data using the fit method, where xtrain is the feature data and ytrain is the target labels. To make predictions, provide a new data point in the same format as the training data. For example, new data point equals 3542. Employ the predict method on the fitted model to predict the class of the new data point. Finally, print or display the predicted class. In a real-world scenario, imagine you have a data set containing measurements of flowers with features like sepal length, sepal width, petal length, and petal width. By following the steps outlined above, you can train a KNN classifier to predict the species of an unknown flower based on its measurements. K-nearest neighbors, KNN, is a simple machine learning algorithm that does not require a training phase, making it easy to implement. It is well suited for small datasets due to its simplicity and minimal pre-computation. However, KNN becomes computationally expensive when dealing with large datasets, as it necessitates calculating distances between the new data point and all existing data points. Moreover, this algorithm is sensitive to irrelevant or redundant features, which can compromise its accuracy. In scenarios with high-dimensional data, KNN tends to be slow and inefficient. Its limitations make it less practical for real-world applications that involve extensive data processing needs. K-nearest neighbors can be likened to asking your neighbors for a cup of sugar. In the same way, KNN algorithm finds the nearest neighbors of a data point based on its features. The algorithm calculates the distance between data points to determine similarity. By looking at the characteristics of the closest neighbors, the algorithm predicts the classification of a new data point. This can be converted into a program by defining a function that calculates distances between data points and determines the majority class of the nearest neighbors to make predictions. Hey, code conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The K-nearest neighbors (KNN) algorithm is implemented in the provided Python code using a simple text analogy as a scenario. Let's break down the technical details. 1. The code starts by importing necessary libraries like NumPy for numerical operations and counter for counting unique elements in a list. 2. An analogy is set up regarding requesting sugar from neighbors. 3. A sample dataset neighbors data is created where each neighbor is represented by their name and sugar flour availability. 4. The Euclidean distance function is defined to calculate the Euclidean distance between two data points. It uses the NumPy library to find the norm of the difference in feature values. 5. The predict sugar availability function is defined to predict the sugar availability for a new neighbor based on the KNN algorithm. It takes the new data point, the existing neighbor's data, and the parameter k, which represents the number of nearest neighbors, to consider. 6. The function calculates the Euclidean distance between the new data point and each existing neighbor, sorts the neighbors based on distance, selects the k, nearest neighbors, and determines the majority class, sugar availability, among them. 7. A new neighbor is defined for which we want to predict sugar availability. 8. The code then calls the predict sugar availability function with the new neighbor data, the existing neighbor's data, and the value of k, set to 3 in this case. 9. Finally, the predicted sugar availability for the new neighbor is printed based on the majority class of the nearest neighbors. This example showcases how the K-nearest neighbors (KNN) algorithm can be utilized to make predictions based on the similarity of data points in a dataset. In a real-world scenario, KNN is commonly used in recommendation systems, image recognition, and anomaly detection. One industrial application of the K-nearest neighbors (KNN) algorithm is in recommendation systems. For instance, online platforms like Amazon or Netflix utilize KNN to recommend products or movies to users based on similar users' preferences. By calculating the similarity between users or items using KNN, these platforms can suggest items that users with similar tastes have liked in the past. Another real-world example of KNN is in the field of healthcare for predictive modeling. KNN can be used to predict the likelihood of a patient developing a certain condition based on the characteristics and medical history of similar patients in the dataset. Healthcare professionals can leverage KNN to make informed decisions about patient care and treatment plans by identifying patterns from the data of similar patients. Overall, KNN algorithm finds its application in diverse fields for pattern recognition, classification, and regression tasks based on the similarity of data points. Across the globe, various industries benefit from the implementation of the KNN algorithm for making data-driven decisions and providing personalized recommendations. Keep learning, stay curious, and I'll catch you in the next video.